Just like we could use our angles with our parallel lines and our transversal to do problems using algebra, we can also do that with proving that lines are parallel. So if we look at that, we're still going to look at our angles and the converse that could be used to prove that the lines are parallel, and then we're going to actually find what x would equal. If we look at example number 1, we have that 10x minus 23 and 137 are our alternate interior angles. So that's the converse that we would be using, our alternate interior angles converse. And if we want to use that, we're going to have to set these things equal to each other because alternate interior angles are congruent. So when we do that, we get 10x minus 23 equals 137. And when we solve, we find that x equals 16. So if x equals 16, then we can use our alternate interior angles to say that line A and line B are parallel. For number 2, we have these two angles and they are corresponding angles. Corresponding angles are congruent. So if I wanted to say that these lines are parallel, I would need to set these things equal to each other to find my x. When I do that, I get that x equals 7. So if x equals 7, then I can say that I can use the corresponding angles converse to say that line A and B are parallel. Number 3, notice that our expression has an arrow pointing to the angle it's actually referring to, and these angles are our consecutive interior or same side interior angles. Same side interior angles are supplementary, so we're going to add those things and set it equal to 180, and then when we find our x, we get that x equals 19. So if x equals 19, then we can say that using our converse of consecutive interior angles, line A and B are parallel. For number 4, we have our 33 degrees and our 7x plus 5. These are alternate exterior angles, which means they are congruent. So if we set them equal to each other and solve for our x, we get x equals 4. When x equals 4, we have our alternate exterior angles converse that can be used to prove that lines A and B are parallel. Number 5, we have corresponding angles. Notice that both things are algebraic expressions. So I'm going to set my algebraic expressions equal to each other to solve for my x. Once I get my x, I can say that when x equals 12, I can use the corresponding angles converse to prove that lines A and B are parallel. For number 6, we have our angles on the same side of our transversal. So these are consecutive exterior angles or same side exterior angles. They are supplementary, so we're going to add them together and set it equal to 180 degrees to find that x equals 13. When x equals 13, we would say that we are using our consecutive exterior angles converse to prove that lines A and B are parallel. A couple more examples, all doing the same thing. For number 7, we have our alternate interior angles, so we're going to set them equal to each other. When we do that, we find that x equals 21. So we're using those alternate interior angles converse. Number 8, they gave us one expression, 4x minus 18. And then notice they gave us our right angle mark there. Remember, our right angle is 90 degrees. Those are corresponding angles, so we're going to set it equal to 90 degrees and find that x equals 27. And that's our corresponding angles converse. Number 9, I have alternate exterior angles. Remember, alternate exterior angles are congruent. So we're going to set them equal to each other to find that x equals 5. and we're saying our alternate exterior angles converse would prove that lines A and B are parallel. The last one for number 10, again, we need to pay attention to those arrows to make sure we're looking at the correct angles. These angles are same side interior angles, or our consecutive interior angles. That's the converse that we're using. When we do that, they are supplementary, so we're going to add them and set it equal to 180 degrees to find that x equals 11. So when x equals 11, I would use the consecutive interior angles converse to say that lines A and B are parallel. So still doing the same thing that we did using those angle properties to find our missing information, but now we're just saying that it's the converse of the angles that allows us to do that. And that's to prove that lines are parallel with algebra.